Let's take a look at Module 1, an Introduction to AI. Now in this module, we're going to look at the following concepts. We're going to look at artificial intelligence in Azure. We'll try and understand what artificial intelligence is, some of the common AI workloads, and how we can go about implementing those workloads in Azure. What are the services that we can use? Then we'll take a look at responsible AI. What are some of the challenges and risks involved in building AI solutions, and what are the principles that we should apply to mitigate those risks? So lesson 1 is about artificial intelligence in Azure. And we'll start off by thinking about what artificial intelligence actually is. And a simple kind of working definition is it's software that imitates human capabilities. It tries to emulate the way a human interacts with the world. Now that might mean using some past experience and data to make decisions about things. It might mean recognizing when something's not right, recognizing anomalies or when something's abnormal. It might be about interpreting visual input, so using cameras or digital images or videos to understand the world around. It might be about understanding written and spoken language. And it might even be about engaging in dialogues and conversations with users through bots or voice-activated assistants or that type of thing. So there's lots of different ways that we can think about artificial intelligence, but a good sort of summary or a good way to think about it is software that's behaving like a human. It's interacting with the world in human-like ways. So some of the common workloads associated with artificial intelligence. Machine learning is really the kind of foundation for a lot of modern artificial intelligence. And machine learning is about building predictive models. We take some existing data, we train a model based on the relationships that are in that data, and then we use that to make predictions about future data that we get. So machine learning is obviously a fundamental workload that's associated with AI. Building on machine learning, there are things like anomaly detection models. So systems that understand over a period of time, over a time series, how things ought to look, how certain values ought to be, and then understanding when they deviate from those norms, when we get abnormal behavior. So a good example might be a system monitoring a car, and it knows that over the course of a journey, the oil temperature will vary between certain values, or the brake temperature might vary between certain values. But if it goes outside of those values, it detects that as an anomaly, and it can intervene and perhaps give a warning or put some preventative maintenance in place. Computer vision is about applications that interpret the world visually. So typically taking digital images from cameras or from video files and being able to understand what the world is around them, interpreting the different objects that it finds and reacting to the presence of those objects, or interpreting things like text. Being able to read text is a good example of a computer vision application. Now, if we can read that text, we might then want to make some sense of it. We might want to understand that text. And that takes us to natural language processing, where we build systems that can understand written or spoken language, and they can make sense of that language and respond appropriately and interpret semantically what the meaning of that language is. And building on that, we have the ability to create conversational AI solutions that can engage in dialogues with people and manage a sensible exchange of messages back and forth to form a conversation. Now in Microsoft Azure, there are quite a few different services that we can use for building AI solutions. First of all, just generally in Azure, Azure itself is a cloud platform, which means it provides things like data storage. So we've got the ability to store data that we might use for training machine learning models, or to store the data that users are feeding into those models to get inferences or predictions from. It allows us to manage compute, so we can create a very highly scalable compute clusters in Azure that will scale up when we need them, perhaps to train a machine learning model or to run a particular workload, and then scale it back down when we don't need it, so we're only paying for what we need. And then there are built-in services in Azure that are available for us to use and build on in order to create AI solutions. And some of those services we've listed here. These are the ones we're going to focus on in this course. Azure Machine Learning, as its name suggests, is a service for machine learning. It's a service for training machine learning models and then managing those models and deploying them as services so that applications can use them. So we'll take a look at Azure Machine Learning and how we can use that to build our own machine learning predictive models. There are a suite of cognitive services that are available through Microsoft Azure, and these provide application programming interfaces, or APIs, that software engineers can use when they build applications. So they can use these services to add AI capabilities to applications, and there are services for things like computer vision or text analytics or language understanding, and we can build on top of those. And then there's the Azure Bot Service, which is really a framework for building conversational AI solutions. It enables us to write bots and deploy those bots through different channels. So for example, through a web chat interface or by responding to email or in a Teams channel or something like that. So we can build these bots that can manage a dialogue between the back-end logic, which usually has some sort of AI component to interpret the incoming messages and respond appropriately, and then send those messages back conversationally to the end user. So we can see some of the capabilities that there are in AI, and we can see some of the things we can do with Azure. There's a sense in which we need to think about how to be responsible when building AI solutions. So we need to take a look at responsible AI. Now let's think first of all about some of the challenges and risks that are inherent with artificial intelligence. There's a certain amount of press out there and a certain amount of feeling that people are a little bit nervous, a little bit apprehensive to trust their day-to-day lives with artificial intelligence. And that's understandable. There are definitely challenges and risks that we as people who build AI solutions need to be aware of. So one of the first things is there's the risk that bias that we perhaps weren't aware of, or that is just inherently in the data that we used to build a model, might affect the results. And a good example of this might be you might build a machine learning model as part of an AI solution that approves loan applications. So maybe you work in a bank, and when people come in, they apply for loan, and we run the application through this AI system that approves or recommends for approval or non-approval of the loan. Now, it's possible that the data that we use to train that model might be imbalanced. We might have a high proportion of data from male applicants who have successfully repaid their loans, and maybe a very low volume of data from female applicants, or maybe all of the loan data that we have for female applications happens to be people who haven't paid their loans, who've defaulted on their loans. Now, that doesn't mean that male applicants are more likely to repay than female. It just means that our data had a bias in it. But that bias could then influence the model. So when the model comes to predict whether or not somebody's going to pay back their loan, it might not reflect the reality because it's basing its prediction on the bias that's in the data that it was trained with. So we have to be responsible when we're training machine learning models and when we're building AI solutions to be aware that that bias that might be inherent in the data will influence the way that the model behaves. So we might want to make sure that that data isn't biased, that it's well balanced, and be careful about creating those models and understanding why those models are making the predictions that they're making. Now, another risk that we might have is that if we have an AI solution, there is a chance that it could cause harm. If something goes wrong, that system could cause harm. And the most obvious example, I guess, is something like an autonomous vehicle, a self-driving car. It's using AI systems to navigate. But of course, if something goes wrong, then that could crash and that could potentially cause some harm or even a fatality. And it doesn't even have to be something as physical as that. We might have an AI system that takes in patient symptoms and then diagnoses the condition and prescribes some sort of medication. But of course, if that system is not aware of any allergies to medication, or if prescribes the wrong dosage or something like that, then that in turn could cause harm. So there are risks that our AI solutions might cause harm. We need to be aware of those, and we need to be careful to try and mitigate those risks as best we can. Now, another thing we need to think about is that most AI solutions are built on machine learning models, and machine learning models rely on a lot of data to train the models. And then even after the model is trained, we might well have data that is submitted to the model or submitted to the AI solution in order to use it, in order to get some sort of prediction. So, for example, you might have a diagnostic bot for a medical case, and we train that using sensitive patient data. Now, we need to make sure that we store that data securely. We need to be sensitive to the fact that that data is not something that we want to make public, that we want people to have access to. So it needs to be anonymized, it needs to be stored securely, and we need to be protective of that data. Another problem is that some solutions might not work for everyone. We need to think about different audiences for our solutions when we build them. So, for example, you might have some sort of predictive application that is purely visual. It doesn't have any kind of audio output. Now, if you're a visually impaired user, that's not going to be any good to you. You're immediately excluded from being able to use that app. So we need to be careful about the idea of building AI that isn't available for everyone to use. Then we start to get into the thought that AI is inherently quite complex. It's sort of a black box solution that does something, and maybe we're not quite sure how it's reaching those decisions, how it's making the decisions it's making. So because of that, users might find it difficult to trust these systems. We might have an AI solution that seems to magically predict something or magically do something, but if you don't understand how it's coming to those conclusions, it's very difficult to trust that that system is always going to work. So if it's making recommendations on how you should invest your money, for example, how do you know that you should trust it? And then there's the liability question. So if we start to rely on AI day to day, who's responsible when AI gets it wrong? Or when AI makes a decision, who's the person who stands behind that decision and says, yes, I'm accountable for that decision? So for example, if we use facial recognition and it maybe has a 98 or 99% accuracy when tested, but there is the risk that someone could be identified through facial recognition and convicted of a crime that they didn't commit. Who's responsible for that situation? We need to think these issues through carefully before we start to use these types of system in our everyday lives. Now, to help us address all of these problems, I don't want to paint a big picture of doom and gloom and we shouldn't use AI. We should use AI, but we should do it responsibly. And what the engineers at Microsoft do is we have 6 principles of responsible AI that we consider when we're building AI solutions. So we talk about fairness. We try and design solutions that are inherently fair. We remove the bias as much as we can from any data that models are trained with, and we test carefully to make sure that bias is not inherent in the models and the solutions that we have. So it's even-handed, it's fair for everybody who's using it. Reliability and safety is a very important consideration as well. We have to test very carefully all of the systems that we build to make sure that they are not putting people at risk, that there are safeguards in place, that it's reliable, and when something goes wrong, that it knows something goes wrong and degrades gracefully or gives us some kind of error or explains what the problem is. Privacy and security is obviously a concern. If we've got people's data that we're using to train a model or people are submitting data to our systems, we need to be very sensitive to the fact that that data is private, and we need to make sure that it's not shared publicly, it's not available for people to get access to who are not authorized to access that data. And then we need to think about things like inclusiveness. We need to make sure that the AI solutions that we build are available to everybody. They should drive the society forward for everybody. They should improve life for everybody, not just for a certain subset of society. And one way that we do that is to try and include people from all sorts of diverse backgrounds in the building and testing of these solutions as we bring them to market. So making sure that it's a solution that works for everyone. Transparency is important as well. Transparency is about making sure that we're very clear about what our systems can and can't do. So make it very clear when someone is using an AI system, these are the limitations of this system. This is what it can do, and this is how well it can do it, and here's what it can't do. So just being very, very clear that there are boundaries in the capabilities of these systems, and we want to communicate those. And then finally, accountability. We want to make sure that our developers take accountability for the solutions that they build. And we encourage our partners who are building AI solutions to take that approach as well. So being accountable for working within the framework of legal and ethical guidelines for building these sorts of solutions, and standing behind those principles and making sure that we are responsible for that. Now, there is a website on the slide here, the Responsible AI website. And I do encourage you to go and take a look at that. Here it is here. There's all sorts of interesting resources on here. There are videos about those different pillars that we just talked about that you can view. And there's all sorts of information about how we apply those principles, and different resources that you can review to help you as you plan to build AI solutions responsibly. So it's time now to do a hands-on lab. And this lab involves going to a website, the website on the slide there, where you'll find an interactive demo that's basically a card game. And we'll use that to explore some of these principles of responsible AI. So let's go and have a look at that. And when you get to that website, it will look like this. There's a couple of spaces for card decks, and there are decks of cards at the bottom here. So we'll grab the first card from that first deck, and it appears up here. And you can see that what we've got here is for any human-computer interaction, any time when AI is interoperating with a human, some of the things that we need to do over the course of an interaction. So in this initial stage, we need to make it clear what the system can do. And there's an example here of, in PowerPoint, the Quick Starter builds an outline, helps you get started, and it displays suggested topics that help you understand. So it's making it clear what it can do as a system. And similarly, the Bing app shows examples of types of things that you can search for. So you go to the Bing site and it tells you, hey, you can use me to search for news and restaurants and movies and images and all those types of things. And if you have an Apple Watch, it displays the metrics that it tracks. It tells you very explicitly, these are the things that I can track. So this is about being transparent. This is about making sure that you're clear about what are the limitations, what are the capabilities and limitations of this system. And I'll bring up the second card from there as well. And in this case, we're making it clear how well the system can do what it can do. So again, we're being clear about the capabilities and the performance of the system. So in Office, for example, the companion experience ideas, it docks alongside your work and offers some assistance with grammar and design and various other things. It uses this unassuming term ideas, and in this case there's a preview label, to set expectations around how effectively this system can work. And similarly, if you are using Apple Music, for example, the recommender uses language like we think you'll like. So there's an element of uncertainty in there. Just to be absolutely clear, this isn't 100% you will definitely like this. It's we think you'll like this. So it's kind of softening that language just to make it a little bit clearer that there are some limitations to how well this system will perform. If we skip through a few there's another one here, mitigate social biases. And this speaks to that idea of bias, that idea of being fair, making sure that we are being inclusive for people who are using it. So the example here is in the calendar, there are icons in there, but they're gender neutral. We're not being specific about genders in this instance. So we're trying to be inclusive to every user who's going to work with this system. So you could spend a few minutes in this lab going through the various different cards and have a look at some of the guidance and some of the examples that are there and think about how those relate to those principles for responsible AI. So in this module, we talked about artificial intelligence in Azure. We explored what it is, some of the common workloads associated with AI, and the services in Microsoft Azure that we can use to build AI solutions. And then we turned our attention to responsible AI and looked at some of the challenges and risks associated with AI and some of the principles for building responsible AI solutions that we have at Microsoft. Well, there's always more to learn, and you can explore a little further on Microsoft Learn. We have a learning path up there with a module that dives into some of the topics we've talked about in this module in a little bit more depth. So let's take a look at that. And here's that learning path. Get started with artificial intelligence on Azure. And there is one module in this particular learning path called Get Started with AI on Azure. And there are various units in that module that you can work your way through. If I just start on the first one here, we get an introduction to AI, and there's a video there. And each of these units, you can work your way through all the units in here, has some additional information over and above what we've talked about in this particular module. If you have a look at the final summary unit here, you'll see that there's a knowledge check there that you can use just to make sure that you've understood the main concepts and that you're ready to move on. So we do recommend that after the course you go and take a look at this module on Microsoft Learn just to consolidate everything you've learned.